Hi! Hello! Welcome back to Gillesania Engineering Videos, your daily supply of solutions to engineering problems. If you like what you see, please subscribe and don't forget to hit the bell icon so that you'll be notified every time we upload new videos. In this video, we will solve problems in civil engineering. Mostly recent board exam questions and other similar problems. So we have these solved problems in civil engineering. And by the way, this is coming soon to our new tier. We call it the GERTC Plus. So at present, we have our GERTC Lite, in which you will enjoy all our review courses for 13 weeks. Yung 13-week review namin at the palm of your hand. And that is very affordable. It will only cost you 499 pesos for 30 days. 30 days after you join. No? You can pay through GCash or through PayMaya. Okay? And coming soon is our GERTC Plus. So, coming soon pa yun. And this feature that we are going to discuss today, itong ipapresent ko sa inyo, is part of our GERTC Plus. In our GERTC Plus, you will enjoy all the features of our GERTC Lite plus yung mga solved problems, particularly yung mga recent board exam questions. Okay? So, I hope you will learn a lot from this video lecture problems. Okay? So, let's have another recent exam, November 2019. Given the following data of a rectangular type column. Ayan, ito, May 2019, lumabas din kagaya nito. We'll have it in our playlist soon. So, Kn, Rn, rho, reduction factor, phi given. If the column dimension is 550 by 550, so square siya, determine the design axial strength of the column. The design axial strength. Alright, if the column dimension is ganun pa rin, determine the design moment. And using a steel ratio of 0.03, what is the required column depth with the same gross area as the original? Alright, okay, so we are given here the interaction diagram. So ito yung binigay niya. Ito, any unit will do here, no? Basta yung FC prime mo is 20.7, ang Fy mo is 414. So any unit will do kasi dimensionless naman itong Kn. Kn is Pn over Fc prime Ag. So that is unitless. Rn is Pn E divided by Fc prime Agh. Ayan. So, okay. So, paano to? Paano to gawin? So, we have our solution. So, of course, kunin natin muna yung gross area natin. So, it's 550 by 550. So, the gross area is equal to 302,500 square mm. Okay, let's have part 1. So, ang tanong dito is the design axial strength. So, we are given the value of Pn and Kn. Pn and Kn. So, from here, so with known Kn, so Pn is equal to Kn multiplied by this quantity here. Okay, galing dito. Tira natin. So, Pn is equal to Kn times Fc prime Ag. So, it's very easy talaga. Kn is equal to 0.6. So, 0.6 Fc prime is 20.7. And then, Ag is equal to 302,500. So, our Pn, Newton yung lalabas dyan. Convert na lang natin to kilonewton. So, 3757 kilonewton. And the answer is letter D. So, the question is, sorry, not yet letter D. Ang tanong pala is the design strength. So, that's still the nominal. The nominal strength. So, the design strength is VPN. VPN. Discussion na tayo, no? Dapat pasahin talaga yung problem. So, VPN, V is 0.65. So, that will be, alright, 2242. The answer should be letter D. Letter C. Inulit ko pa yung mali ko. Okay, letter C ang sagot. So, ganun din. Pangalawa naman, ang moment. The design moment. Okay, design moment. Okay, so VMN. So, PMN. Part 2. So, part 2, the same Ag pa rin tayo, 550 by 550. So, here we are given the value of Rn also. And take note, Mn is the product of Pn times E. So, with known Rn, makukuha natin yung product Pne. na Rn times the quantity Fc prime Ag times H. So lahat na yan ay known, no? By the way, yung H natin is 550. Square naman yung column natin, no? 550 yung H, 550 din ito. Okay, so substituting the values, ang lalabas dito ay Newton millimeter. So divide mo na lang ng 1 million, no? Para maging kilonewton meter yung value niya. So that's 964, but that is still the nominal strength. Ang tanong dito, the design strength Vmn, that will be V is 0.65. So you have, ayan, 964.3. Okay, so 626.8, letter D. Okay, baka yung iba dyan, iniisip nila, sir, hindi pa 0.9 yan? Kasi moment, kasi yung expo sa 2001, ganun yung mindset. Ay di ha, for columns, the moment and the axial load have to be applied. I-apply natin the same reduction factor. Okay? And for 2010, 2015, that should be 0.65 kasi this is compression control. Alright. Except lang kung nandito ka na banda, na maging tension control na siya. Na? Somewhere here. Saan yung tension? Ito. Ito, tension control to. Ito, transition zone banda. Ito. Ito na range, transition zone yan. Ito, tension control. Alright. Okay, next question. Using a seal ratio of 0.03 and Kn of 0.6, what is the required column depth H? With the same gross area. So, the same gross area pa rin tayo. So, let's have the third part. So, the same gross area and ang ating MNPN, the same pa rin. The same pa rin lahat. So, ang binago lang dito ang ating depth. Ang ating column depth. Alright? So, our Kn is equal to 0.6. Binigay yung Kn pa rin. So, paano ito gawin? So, given ang Kn as 0.6, so somewhere here, 0.6. Ayan. No? And then, the rho is 0.03. So, 0.03. Ito. 0.03. So, ito yung 0.03. So, this point here, intersection. Ayan. So, that will give us a value of Rn approximately 0.23. Lagpas ng 0.23. A little lagpas ng 0.23. So, I just have it as 0.231. Approximately. So, 0.231. Ang hinahanap dito ay H. Alright? So, with known Rn, makukuha natin yung value ng Rn over Kn. Makukuha natin kasi yung Kn natin is 0.6. So, the ratio of Rn over Kn, if you divide this quantity by this quantity, ayan ito yung Rn ito yung Rn, ayan. Ito naman yung Pn, Kn, ito yun. Makakancel yung Pn, Fc prime Ag, ang matitira dyan ay Rn over Kn equals E over H. Eccentricity over H. Alright? So, makukuha na natin ngayon yung ating eccentricity value niya. That is Mn over Pn. Mn over Pn. Kasi the same Mn and Pn din naman. So, Mn over Pn, and that is equal to 964.3 divided by 3757. So, the eccentricity required for this column is 256.67 mm. Okay? So, with that known, ang E natin, ang Rn, Kn known, makukuha natin yung H. Okay? Take note, Rn is already solved. Kn is given in that problem. Kinuha lang natin yung E based on Pn and Mn. The same loading as in the previous questions. Part 1 and part 2. Okay, so with that known already, your H is equal to E times Kn over Rn. Cross-multiply lang natin yan. So that will give you yun. In mm, the answer is 667 mm. 667 mm. Yun. So we will choose here letter A. Alright? Okay? Pero may comment lang ako dito sa question na to kasi with a changing value of H, I doubt your gamma. Ano yung gamma? Tingnan niyo yung graph. Kasi yung gamma mo, mag-change yan din. Assuming the same covering, the same D prime, your gamma will change. So, probably, your graph will also change. Kasi gamma, this graph is only for gamma of 0.8. Pero, hindi na siguro kinonsider yun. Assuming lang, the same gamma pa rin. So, meaning, valid pa rin gamitin itong diagram na to. With changing value of H. But, it has to be taken into account. Kasi kung lalapad yung lalapad yung column mo, then the same D prime, magbabago yung gamma mo. Again, gamma is the ratio of this. Ito siya to the H. So with D prime constant, pag mag-change yung H, mag-change yung gamma. I hope you get my point. But anyway, yun man yung tanong niya dyan, then okay lang. Alright, so that's it for this problem. So let's have another problem. Okay, another situation, problem number 71 to 73. And again, this is November 2019 exam. Okay, a flat steel bar is 5 mm thick by 50 mm wide by 30 mm long. E equals 200 GPa. The bar is bent by moment applied at its end. Okay, so unang tanong, the radius of curvature of the bar if the maximum bending stress is 102 MPa. Pangalawa, determine the moment if the maximum bending stress in the bar is 145. And pangatlo naman, the deflection if the applied moment is 0.2. Okay, so November 2019. Ito yung bar natin, 50 mm by 5 mm thick and then 300 mm long. Ayan, 300 millimeters long. So it will be bent by a moment at the end. So probably, of course, to bend it easily, with ease, dito talaga yung ating bending. Diba? Imposible naman kung dito, hindi mo mabebend dyan. Sino bang malakas na mag-bend along that? The weakest axis is this one. Ito yan. So dyan natin i-bend. So pag binend natin at that, it will become like this. Ayun, So the moment is unknown in this case. So 300 mm itong length na yan, the arc of that 50 by 5. Ito yung ating radius of curvature. And the angle is theta here. Angle is theta. So in the first part, given ang kanyang bending stress. The bending stress is 102 MPa. So there is a formula for this. So again, meron akong sa lecture sa review, didiscuss ko to, diderive ko pa nga to. Hanapin nyo under stresses in beams. Meron doon, may derivation ako doon. So R is equal to E times C divided by FB max. E times C. Diderive ko to. Tingnan nyo doon. Hanapin nyo lang sa playlist. Nandoon ito sa playlist. Alright, E is 200,000. Ang C natin is kalahati ng 5. Of course, ang FB max is given as 102. Makukuha natin yung ating radius of curvature. In mm yung lalabas dyan. 4,902 mm or 4.9 meters. No problem. Okay, that's part 1. Part 2. The moment if the maximum bending stress is 145. Ito mas madali ito. What is the bending moment? So, given ang maximum stress, and take note for this section bent about this section here, 550 by, draw ko lang, 50 by 5, ito yon. Ito yung axis of bending natin. So, ito yung 50, ito yung 5. So, we can use the rectangular formula 6m over bd squared. Our b is 50, our d is 5. Ang tinatanong dito is the moment. Known ang bending stress, 145. So, direct substitution, then the answer, ang lalabas dito, Newton millimeter. 30,208 Newton mm or divide natin by 1,000, 30.2 Newton meter. Okay, that's the answer in part 2. Okay, next, part 3. Part 3. The deflection. The maximum deflection, of course, nasa gitna yan. If the applied moment M is 20 kilonewton meter. So, how do we find the deflection? And where is that? So, look at this big part here. So, ito yun. Ito yung bent figure natin or elastic curve. Ito yung original position niya. Ito yung maximum deflection natin. Yung delta dyan. Delta. Okay? So, first kunin natin muna yung radius of curvature. So, the same formula kanina. In this case, we will use the one in terms of M na lang. No? Another formula is EI over M. Yung kanina ginamit natin, EC over FB. Pareho din yan. Pwede mong ma-derive yan. Again, dinerive ko to in one of the lectures in the review. Panoorin nyo lang. You have access to those videos. EI over M. Okay, yung E natin 200,000. Yung I natin is BD cube over 12. 50 by 5 cube over 12. Ang M natin is 0.2 kN/meter. Convert natin to Newton millimeters here. So, makukuha natin yung R. Ang lalabas dyan, mm. Okay, so paano natin kunin yung delta? Now, to solve for delta, remember simple curve. Sa transportation natin, sa simple curve, that delta is the what? Can you remember that? Ito yung radius curve, ito yung central angle. Ano yung delta? In a simple curve. That is the middle ordinate. So, we need your theta. Your theta can be solved. No? Your L, meaning the length of this arc here, is 300 and the radius is known. From geometry, the length of arc C or L equals R times the central angle. Makukuha natin yung central angle theta, that will be in radians. I-convert na lang natin to degrees. No? So, times 180 over pi, that gives us 33 degrees. And with that known already, the middle ordinate, kung sa simple curve pa yan, delta is equal to R, from here to here is R, minusan natin ang R cosine. Ito yun, no? R cosine of theta over 2. R, itong height ito, from here up to here. Gamitan natin ng ibang pen. That will be from here up to here. Ito yung R cosine theta. No? Itong height na ito. Itong height na ito. No? So, R cosine of theta over 2. Substituting the values, the answer is 21.45 millimeters. Okay? So, the answer is letter A. Ayos pa?